Consciously trying to make it as simple as it can be, but don't mistake simplicity for something that doesn't give you interesting results, quite the contrary. If there's one rule that you take away from this class, it will be take the average of each segment in the data. That is probably the single most most widely applied kind of analysis that I see. Just take a data set, divide it into groups, find the averages by group, compare them, and just that is enough to do almost all the analysis that is being done today in the world, to a degree of about 90% plus. Let's dive deeper into that. So what I've got here is a snapshot of a data set, which is from Tesco's website. Tesco is a retailer. They sell groceries among other things. And what we have here are the category of the product. It's a much larger data set, by the way, which we put together by scraping their website. I'll just show you one page of it. You have the category of the product, you have the name of the product, the energy content, and the price. The energy content is in kilojoules per 100 grams. And you can convert that to calories if you like. The rate is in pounds per 100 grams. So on a per 100 gram basis, how much energy is it giving you and how much does it cost? Now, one of the simplest things that we can
repeat, the energy is the number of
kilojoules per 100 grams.
No, for what?
For the product. So if you took, let's say, Activia pouring vanilla yogurt, then that for every 100 grams has 263 kilojoules.
As in the calorie intake?
As in calorie intake. And costs 21 pence per pound, per 100 grams. So what we've got is the categories, the energy, the calories and the cost. So one of the easiest things to figure out is how does the category affect the calories and price per kg? Or in other words, which categories of food are light, which are the inexpensive ones? Let's do that. Here's the result of breaking up by category the average calories, the average kilojoules. So it looks like snacks have a lot of calories, followed by cakes. This is all per 100 grams, so you know that it's comparable. Absolutely no surprises here. Snacks and cakes, fine. Cereals, fairly high. I don't know if you were expecting that. Ice creams in the middle, desserts, get in the middle, bread somewhat lower, dairy, fruits and vegetables among the lightest things that you can eat.
I'm surprised the vegetables are higher than fruit.
I guess it's...
Because fruit has sugar in them.
Let's keep that thought in mind, because what will then be interesting to explore is to see which are the vegetables that are contributing to higher averages. And we will.
If you put potato into vegetable, I'm guessing it's going to skew into what?
So that's a hypothesis. Potatoes are moving it up significantly. Now, what do you think would be the price averages? Which would be the most expensive? Which would be the least expensive? Which do you think would be the most expensive?
Desserts.
Desserts.
Cakes.
Fruits, dessert, cakes. Dairy products, snacks.
By this, if you go, fruits should be the most expensive because we want least calories.
Which is interesting. No? I spent 2 months trying to live on as low a budget as could be. I said, is it possible to live in London for 50 pounds in 1 month? Which is a crazy target. So I ended up having to then break it up into food and transport and everything else, because transport was impossible target to meet. So I said, okay, outside of transport, which ended up costing about 100 pounds a month at the lowest that I could do it, can I live on 50 pounds a month? Turns out you can, but part of what that involves is making sure you get the most calories for the least price. So you're trying to actually optimize for calories, and in this particular case, it isn't a matter of trying to work on a diet. It's the opposite. How can I get the maximum energy by spending as little as possible? But let's take a look at what this looks like. So cakes are the most expensive, followed by snacks. Fruits are pretty expensive. desserts, vegetables, breads are among the least expensive, which is fine. Now, let's try plotting this. If I take the calorific rate and the price, that's where each of these points lie. So it looks like there's bread, which is not very expensive, provides a reasonable number of calories. I end up eating a lot of these. Then there's healthy foods, reasonably expensive, not too many calories. And then there's the less healthy foods, desserts, ice creams. Interestingly, cereals as well. Now, this is where the difference between good calories and bad calories come in. Calories are not everything. But from a pure energy consumption standpoint, cereals are giving you a good amount of calories for their price. And you could in fact just do a straight line like this and say, for a given price, am I getting more value for money or less value for money? And everything that's to the left, in some sense, is giving you less value for money, fewer calories than the price. Anything that's to the bottom right is giving you more value for money, if you're interested in calories. If you're interested in dieting, then it's the exact opposite. And then there's cakes and snacks, luxury foods, stuff that would give you lots of calories as well as cost you fat, which is fine, which makes for a story in itself. It's just based on taking the averages by each of these segments, and we come up with this piece of analysis. Let's actually do a de-averaging, which is, now that we've got this analysis at the segment level, let's dive deep and see if we can plot the same graph. So low calories to high calories, low price to high price, each of the foods, and rather than the static image, I'll show you a dynamic image which has the same data. Now, let's, unfortunately I don't have vegetables on this list because we have tested this potato hypothesis. We've got the data, we can still do that. Let's say we pick all the cereals. Okay, that's taking more time. No, the cereals are in a light, and what color would you call that? Orange?
Yes.
Orangish color. So, relatively low priced, most of them, and deliver a medium number of calories. But you notice that while these are somewhat clustered, the blue ones, the desserts, go all the way from extremely high calorific value to extremely low calorific value. In fact, let me search for jelly. Much to my daughter's delight, we found that jellies are among the least expensive, least calorie providing foods. So, fantastic. Low price, low calories, have as much of it as you want. Great. Custards too, surprisingly. These, by the way, are jelly beans. Jelly beans aren't such a great idea, but plain jellies, that's fine. Custards too. Most custards are pretty low calories and low price.
But how did you code these? Meaning these are just the official labels for these terms, or have you? So, for example, jelly beans and jelly are not the same kind of entity.
Yeah. Now, the products are themselves grouped into categories.
I see.
And
By Tesco.
By Tesco. So we know the categories, and that's what determines the color. But the search is just searching for the word in the title. So, what are all the products that have the word jelly in it? Or let's see where biscuits lie. Biscuits ranging from low price to medium price, but having very high calorific values. One of the things that completely shocked me when I got back to India was how inexpensive biscuits are. It is mind-blowing. For 5 rupees, I can get a tiger biscuit, which could keep a person going for quite a long time. When we were talking to the head of Rajshri Sugars, which is one of the largest sugar companies, he was complaining so much about the degree to which sugar prices are controlled and subsidized. Sugar is the primary carbohydrate for most people. That's what gives them their sustenance. So if you control sugar prices, then the government has a means of making sure that the poor get fed as well, which is why they're doing it. But his argument was, look, I can see why you would subsidize it for tiger biscuits. That 5 rupees, that's a meal for a number of people. But I have no reason to subsidize it for Coke and Pepsi, who in fact are even larger customers. And that's where the bulk of the subsidy is really going.
It's interesting you mentioned that because there's very important work by Banerjee and Dufflo, so poor economics, I think, which is looking at people who earn $1 a day or less over the last 30 years. They've systematically moved towards sugar as something that they spend money on. So whether it is in tea, biscuits, and I wonder if these kinds, so that there is a, obviously if you want to maximize calorie intake and it is subsidized, obviously you would move towards something which is nutritionally not that
And it
important.
gives you energy.
Nutritionally zero.
So it might be
Calorie.
interesting.
Absolutely. So which means that looking at this, I go for something that costs less, which is lower, which is to the left, and provides a large number of calories. So what is out here? Lots of calories but low price. That's crunchy peanut butter. There's hazelnut spread, chocolate spread. Interesting. If
Chocolate
those
spread?
chocolate spread as value for money, calories per pound, is among the highest in the UK. I don't know how different that would be. My guess is Tiger biscuits would be somewhere out there for Indian data. But what we've done is taken the averages by group, and by plotting something like this, being able to identify what is a good food for people who are dieting, what's a good food for people who are living under $1, for instance, what's a good food for people to splurge on, or what are the kinds of foods, and where one. Let's go to other kinds of analysis that one can do with this. Now, we've used the category column. We've somewhat implicitly used the title by searching for it, but we haven't really done any analysis on it. We've used the calorie rate and the price column. What if we could explicitly use the text here? What if we could explicitly take words out of the text, out of the titles, and say, if the product has this word, then what does it mean? So create new categories out of that. These are the words that occur most frequently out of the full list of products. There's lots of chocolate, there's a fair bit of strawberry and yogurt, fair bit of organic, there's a fair bit of finest. So let's take these three words, and feel free to pick any word, we just do this analysis now, which is trying to find out what can we say about foods that contain the words organic, chocolate, or finest from their calorific rate. Let's see how we do that. I'm going to open the data set. It's not a large file, in fact, this is the smallest file that I've got. What we have is the URL from where we picked up the data, the category of the product, which is one of those categories that you saw, the title of the product, the kilojoules per 100 grams, and the price in pounds per 100 grams. Now, we're going to search for a particular word. Now, when I want to search for a word in a piece of text, usually I find that I want to search for multiple words in a piece of text. This is a standard approach that I follow. I put in the titles as the words, so chocolate, organic, finest, and once we finish this, we add on a few more. What I don't want to do is type a formula every time. So I'm going to type a formula in one cell, which I can just copy and paste across this and get this. Now there is a find function, which will find a particular piece of text. Rather than hard coding it, I'm just going to select the cell and search for it in this page. So if there's an error, then it won't get reported. If there is no error, then it will tell me the exact position. So I'm just interested in if there is an error in this, then report it as 0. That is, the word doesn't exist. Otherwise, report it as 1. So in other words, the word exists. In order to, so this is saying it doesn't exist here. In order to be able to copy and paste it, I'm going to have to put a few dollars around this. So I want to make sure that F1 stays F1 as I move it down, but as I move it left and right, it moves along. So I'm going to put a dollar against the 1, so the 1 never changes. It's always going in the first row. And I want to make sure that things stay at column C, and the columns don't move as I move it around. So with this, I should be able to this clearly isn't common. Let's see, find H1. Okay. Let me replace this with search, which if I'm not mistaken is case insensitive. Whereas find is case sensitive. Yeah, that is. So use search instead of find if you're not aware of the case. Okay. So now we've got three columns which tell us whether the word is present in that group or not. And we can do the usual stuff that we do in the pages. Let's do a pivot table. For chocolates, what is the calorific rates average? And what you see is the presence. Firstly, let's get rid of the redundant digits. We rather want more than 2 or 3 significant decisions. So, on average, chocolates, products that contain the word chocolate have 1.5 times as many calories as products that do not contain the word chocolate. What about pricing? What do you think? They're more expensive chocolates, less expensive?
More
How many more?
More expensive than more.
Than non-chocolates. So we are comparing words that contain products that contain the word chocolate versus products that do not contain the word chocolate. Those are our groups. So products that contain the word chocolates, more expensive?
Less.
more expensive per or more expensive?
More expensive per, everything is on a per 100 grams basis. Okay. Less expensive? It's interesting. Less expensive. I don't know. Let's find out. Take the rate, change that to the average, and let's increase the number of decimals here. So more expensive by a factor of by 25%. So chocolates are more expensive and provide more calories. Fine. What about organic products?
More
Less
expensive.
calories.
We have talked
Less
about
calories,
less
more
calories.
expensive. Okay, that seems to be a consensus. Let's see. So we'll drag the chocolates in, and let's increase the number of decimals. Less calories, yes, but only slightly less. Interesting. And significantly more expensive. So let's see
Less
how much.
calories than what?
Less calories than words than products that do not contain the word organic. Organic products versus non-organic
Inorganic.
products. Let's
But after
I wonder if a lot of
category
it-
itself is is it a category for calorific comparison?
It is now, it is
Because-
just a process rather than a calorific
Yeah.
unit. So,
Yeah.
But a lot of people, when in this room we asked, do you think it will have less calories? Emphatically said less, which means that at least we associate organic with less calories, irrespective of what the process is.
Only means that a lot of organic sugar and chocolate is being sold.
Again,
Because you can have organic,
organic
Chocolate
Everything
bar.
almost,
No,
and
yeah,
yeah.
chocolate spread, whatever. No, true, very true. Let's look at finest. Oh, okay. What do you expect for finest? Finest, by the way, is Tesco's brand category for relatively higher price products. So price, I'm sure you'll be expecting higher, or you ought to. What about calories? Higher, lower? Higher. Let's see.
I'm not saying it.
Calories higher by a reasonable margin. So as a percentage, that's about 13% higher, which is not too bad. Okay. Any other words you want to try out?
So we do chocolate consumptions.
Value.
Let's do organic and chocolate.
Organic and chocolate. Okay, let's do both. Let's do value. And what's your hypothesis here?
I think value would be cheap.
Value ought to be cheaper. Let's check that. And calorie wise, more calories, less price. Value with calories. Interestingly, calories not that different, but price, as you can see, the world of it is almost 3.5 times less expensive if it has a word value. Okay, which obviously does go with the definition, it's good value for money. Okay. Conjunctions. Now let's see what happens if, let's take just the calorific value of chocolate, having chocolate versus organic.
And
Sorry?
we are talking about conjunctions.
Yes, what this does is takes all four possible combinations, which is containing the word, so the columns are chocolate. So no chocolates, yes chocolates. And the rows are organic. So no organic, yes organic. So the combination of, well, this is average, right? Yeah. So if you have chocolate and organic, that just completely creams the market. You're talking about the really expensive products.
So it tells you that organic chocolate is both expensive and fattening at the same
Yeah.
time.
So the
It's ugly.
yeah, but interestingly, if you take non-chocolates, it's the reverse, which is the word organic tends to reduce the calories. Being organic in chocolates means more calories. Being organic outside of chocolates means less calories.
If you cut that out, so if you do the organic minus organic chocolate in the earlier comparison, you might see that the price calorie thing will shift.
Exactly. Yeah. And if we try and see what this looks like for price, let's take this, let's change that to average, and let's just do the coloring. So, chocolates definitely cost more. Organic chocolates cost even more, but organic other things cost less. So it's in line with calories. So if you're buying organic stuff that are not chocolates, you pay less, get fewer calories. With chocolates, it's the reverse by a fairly large margin actually. Now, one could play around like this for a good few hours and come up with story after story about how our products are priced.
So here's a question, and since you've been in Tesco, typically in the supermarket aisles, the organic products are clubbed together. So which is to say that regular chocolates will not be next to regular fruits or other things, or rice or something, but I bet you organic chocolate would be right next to organic cereal and other things, right? So which means that your price, so you are increasing the likelihood that somebody who buys organic wheat also buys organic chocolate, which you won't do if you are far away in the supermarket in the non-organic.
True. What Tesco do, however, is given the way, given I think their analysis on how chocolates are bought, place organic chocolates in both sections.
In both the chocolates and in the organic.
There are a few categories of products that they do it for. So if it fits in multiple categories, place these in all of the aisles. And there is a fairly strong bias for it. Not every retailer can do that. You've got to have the kind of scale and the kind of inventory affordance that lets you do it. So not many people would do it. In more cases than not, organic chocolates are placed with organic wheat, for example, based on the kind of produce. But these guys know enough to place it on board, and specifically with regard to chocolates. But don't find organic wheat with the wheat section or any other kind of product. So who knows what's going on
Organic
there.
chocolate is a profit center, I'm sure. Really.
And also the profit of conversion is a lot higher.
So I'm sure there are people who actually are purchasing organic and not cereal or chocolates. So that's another story, another profile.
True. And one can start digging at what is the relative pricing of those kinds of products. Like I said, one can spend a good few hours just with this data, playing around with nothing more than averages. Take the average based on this group, that group, and the maintenance really comes in coming up with new kinds of groups and combinations of groups. Let's go to a different data set. This is a data set that some of you have taken up as a project. It contains the marks of every student in Karnataka who took the SSLC exam in 2011. This is the structure of the data set, and because it's a project for some of you, I'm going to go through the fields in a little bit of detail, or at least I'm going to talk through most of the fields. What we have are the district codes, which we can easily map onto the names of the districts. The district code, incidentally for your information, is not only districts, there are a few cities as well. So Bangalore, well, Bangalore rural and urban is a district, but Bangalore urban is broken into Bangalore North and South. Sirsi is considered a district, though it's not really a district. And a few other cities are there as well, but by and large, most of them are districts. And the school code, the registration number of the student, their date of birth. The date of birth is in a DDMMYY format. So this 3-10-03 means that they were born on the 3rd of October 2003.
No, that can't be.
9 years old.
So either they were born in 1925
I think the Excel hasn't converted. Yeah, probably.
Yeah.
I think it's in the value. It got
Oh,
converted.
sorry, okay. No, yeah, that's right, yeah. These are the number of days starting from January 1st, 1980. But the original data is in the form DDMMYY, which in the data set that we will get, I have converted into a normal date format, and yeah, no, it's not this bad. We have the student's name, their mother's name, their father's name, the caste code, the gender code, girls or boys, the medium of instruction, English, Hindi, Urdu, whatever, their physical condition, whether they have a known disability or not, the center code, where they took the exam, their total marks, the result, whether they failed or passed, and the class distinction, fail, pass, first, whatever. And the name of the school, followed by their marks in the subjects that they took. So, neither of these two students took English as a first language, but they did take English as a second language. Those are their marks. They didn't take English as a third language, they didn't take Hindi as a first language, they did take Hindi as a third language. Those are their marks, and so on. You will find for each student, in the vast majority of the cases, exactly 6 distinct marks. So, what can we do with this data? Keeping in mind that we're talking about taking averages by group.
You can see which districts perform better.
Which districts perform better?
Whether language, English language as a medium of instruction, how it affects the marks
Yep.
versus the language, spoken language.
Absolutely. And you can just get this,
Yeah.
rural versus urban, you can get this down to a simple algorithm. Go through each one of these. For each one of these, calculate the averages of each one of the marks. Just blindly do it. The amount of time that it takes with, say, pivot tables, for instance, is not so high that you may as well just do them all. Let's start with a few.
Sorry, can you just go back? What is the center? That's where it took.
They took the exam.
Does that mean multiple schools? Like what is the,
No, it's one school.
it's one school?
But it may not be a school, it could be some government center, library.
All these are government schools.
These are not necessarily government schools, in fact, 2/3 of them are private schools.
Actually, that might have been an interesting category also.
Yes.
Government or
Exactly.
private schools.
Government versus private.
So what is interesting is every single government school has either the word GOVT or government in full mentioned in the school. We haven't seen an exception. Now, there might be, but we are confident that at least 99% of the cases this is right. So,
therefore we can use
therefore we can-
another segment.
Absolutely.
This is the complete set of SSLC.
That's right. Every single student, about 5 lakh students. I could be wrong about the number by an order of magnitude, but it's a few lakhs of students.
And detail of the schools which are on one trust, which doesn't fall in the criteria. Those are the
Which would be interesting to get. No, we don't have that. The only thing we have is the name of the school. Now, we tried a few things like from the name of the school, can we get the address of the school? It isn't trivial, but we'd love it if somebody were to do it.
There seems to be a huge set of data of all the schools, everything. So I think we're going.
That's what we thought. Now, there we get into the simple problem of spellings, and matching school name from one source with another source is a nightmare. There are various ways of solving. You can get to 95% accuracy reasonably quickly. You can get to 99% accuracy with a fair bit of effort. Getting into 100% is close to impossible. But then that's where for a 1% of the schools, there are about 25,000 schools, 1% of that is 250 schools. can sit for a day and do the manual matching. It's still possible, but it's, let's not underestimate the work. And if you did not attempt manual, I mean, if you did not attempt any automation, then you'd probably be manually matching about 4,000, 5,000 schools easily, which is a few days, possibly weeks.
How about matching district codes to pin codes?
That would be a starting point. So you know that district codes are unlikely to be wrong. They have been in a specific case, and I'll tell you how they could be wrong. But if there are two, you don't need to take a school and compare it with every other school. You only need to compare it with every other school in the same district. Now, where this could go wrong is different databases have different district classifications. So Sirsi, for instance, is not a district in most databases. So you'll have to know that you'll have to, if the district code happens to be one for Sirsi, map it to Shimoga and then do a lookup on the other database. We don't know whether there are cases of schools that actually span district boundaries. Now there are two ways in which this could happen. Districts keep, the shapes of districts do change. Districts get broken up and so on. So depending on, so let us say, for example, you took the data from DICE, which is another educational database, and took the data from 2010. Now in 2010, the number of districts was 630, okay, let me give you precise numbers. So as of June 2011, there were 639 districts. 3 months later, there were 641 districts. 2 districts got added. And this sort of a thing keeps happening every now and then. So depending on where the school was and what the time was at which you got this information, the school could have moved districts. Number of such schools, very small, so you may not have to worry about it. The other reason this could happen is even more academic, it wouldn't happen in real life. But for instance, you may or may not be surprised to know that PIN codes do not align with the administrative boundaries in India. So which means that there are PIN codes that span multiple administrative boundaries. They could go across districts. They could even there are PIN codes that span states. Nobody knows where every single PIN code in India is. It's an open problem. By that I mean there is no single authority that knows exactly where. There are about 25,000 post offices. The post offices know where each of their PIN codes are. So by and large, collectively we know where the 110,000 PIN codes are. There is no central authority, including the Postal College in Mysore, which defines these PIN codes, that knows exactly where things are, except that they are associated with this. Stuff like that could come up, but we're talking about either a 5% problem or a 1% problem, depending on the nature of your analysis. That may not matter. Let's take the districts breakup that, which was pretty much the first call. I've converted the district codes to the district names. So it looks like Sirsi is right on top of the list, whereas Bidar is right over there. What insights could I draw just from this? I'd argue that there seems to be a color shift between these 1, 2, 3, 4, 5, 6, perhaps 7. Between the top 7 and the rest, there is a clear demarcation. And between the last and everything else, there seems to be a clear demarcation. So it's like there are the top 7, there are the rest, and then there is the last. Which is an interesting pattern, meaning by looking at this, one gets a sense of how one classifies this. There is a high, medium, and low. And the size of the high is 7, the size of the low is just 1, and then everything else is in the medium. It also helps to look at it geographically. You can see that Bidar, which is out there, has a serious problem. And most of the coastal areas are doing relatively better compared to most of the interior, with the exception, of course, of Bangalore and the bed that connects Bangalore to the coast. Okay, so that's an interesting story. Now, why is that happening? One can start looking at percentage of government schools in each of these. So add a second factor. Is it government schools that are significantly influencing it? What is the per capita GDP of each of these states? Start adding columns, whatever.
Some of it must just be cost, right? Like Udupi, I'm sure, is government dominated, so there is that kind of thing.
Also, the entire coast has historically been more developed than the interior Karnataka because of its link with Bombay. It was part of Bombay Presidency, and that so all the development indicators are high.
And this is the pattern that is seen in most states actually.
Yeah.
Coastal areas
It's
can
more
be
prosperous, I guess.
Yeah.
So all those are additional factors that one can bring in. Prosperity links to other geographies, or there are internal factors that we could look at, like is caste a contributing factor, are government schools a contributing factor, and so on. So
You said Shirsi is the part of Shimoga, is it?
that's my understanding. Yes.
So it's very different from the rest of Shimoga.
Yes. So, Sirsi as a city is doing much better than Shimoga as a whole.
So in that sense, we could, I mean, again, if we do a past plus location thing, it might be interesting to find out if, for a given caste, what is the variation across the state? Meaning, right? So for example, if you're a lower caste person, is it better to be in a city or in a village or in a small, what kind of stats to run that?
True. No, and a related question would be, as a lower caste person, what is the right choice of subject for? Or choice of subjects? What group should I pick? We'll come to that in a minute. Or even if I don't have a slide for it, we can just do the analysis and find out. Let's take another breakup. This is the month and date of birth. Given the date of birth, we could take every single day that a person is born and ignore the year, take the month and the date and see what the marks look like. So there are a few people that are born on January of an invalid month. Sorry, on the first of an invalid month, which basically means we don't have the data. And where we don't have the data, they score really, really good. We don't know why.
Which is outliers. It speaks of
Martin Gladwell, yes.
It probably means that they don't have parents and they don't know the date of birth and so on.
Quite possibly. In which case, therefore,
Bad
also
situation.
Or you can also look at the caste composition, for
also
example.
look at the caste composition, see if people whose birth dates are missing are relatively small fraction. We also need to look at the numbers and see how large this is. This isn't particularly large. But with this pattern, it's tough to see in it. So let's just take the same data and see what it looks like if you plotted it on a calendar. So that's from January to December. Yeah. The September, October, November, December bonds seem to be doing a lot better. Those born in June, July, maybe a bit of August, not doing so well. Previous months, okay, somewhere in the
This
middle.
is very consistent with Malcolm
It
Gladwell's
is,
analysis
yes.
of hockey, right?
It's also the cutoff date for admissions.
Yes,
That's exactly what it is.
exactly what it is.
So all those who are sort of later born are actually
Earlier born,
Absolutely.
older.
So these are the older kids,
Exactly.
these are the younger kids. But you may also spot a few other patterns. Well, leave it to you. Do you spot any other patterns?
June has a strange.
June's relatively low, yeah. But that is again explainable by Malcolm Gladwell's analysis, which is that June borns tend to be the youngest in the class. They just make it because the school opens only in mid-June or July. And therefore, they'll be the youngest in the class and have a disadvantage there.
Jan has just one.
Friday.
Yeah, Jan first tend to be doing poorly. Now, it's not really easy to see from this, so let me show you a different.
Sundays are bad.
Sundays are bad, okay? Sundays are relatively bad. We'll have to see if that's statistically significant. But let's do that. Let's do the analysis right after
Now
this.
we're getting into astrology.
No, there's far more sinister things at work here. But take a look at this. So this is
People might think astrology is
So that's the month, that's the day of the month. So June doing relatively badly. But people born on the 1st, 10th, 15th, 20th, 25th. We did another piece of analysis to see how many people are on average born on a given day. Okay. I don't have that slide here. I'll just talk you through it. So if you take the US data between 1975 to 1990, you'll find that, well, firstly, you would expect, we went in assuming it would be somewhat uniformly distributed. Turns out that most people are born in the months of July, August, September. But that's easily explainable. That's 9 months after the holiday season. Now, you'll also find, however, that there are very few people born during the Christmas holidays, during the Thanksgiving holidays, during the Easter holidays, during the New Year holidays, during the Independence Day holidays. In fact, very few people born on any holiday. So doctors and hospitals don't want to be disturbed. So this is a time when 60% of the births, this is between 1975 and 1990, most of the births were cesarean births and people could move babies around. But it's not just the doctors. you'll find that very few people are born on the 13th of any month. You'll find that very few people are born on April Fool's Day. But Valentine's Day, huge number of people. St. Patrick's Day, huge number of people. So clearly there's a bit of moving around here and there. We try to see if there's a Diwali effect, there's a
Diwali
kind of thing in India. Nothing of that kind.
They should be born on Diwali.
You'll find, and you can take this data and do this analysis, almost nobody is born in the month of August in India. How many people? No, I mean, well, yes, probably, but would you, for those who have kids, how would you want your 4-year-old to stay at home for a year longer?
So, but people want their children to be born in a certain horoscope, right?
That is true.
I think in India people had so much control in
But
it.
can you
They were saying that
The degree of control is actually low across months.
This shows you the degree of control is high because this is about reporting the birth rather than the actual birth.
Exactly.
right.
So me telling somebody that my child is born in, I don't know, June or July, even though where they are born in August.
And my daughter is one of them.
So that was the US pattern, where you can see that during Christmas, Thanksgiving, nobody born, New Year's, blah blah, and on the 13th you can see a huge dip. Nobody likes to be born on the 13th. The kids to be born on the 13th. This is the pattern for India. August births, very few. Now, our conclusion was that this is cooked up.
This is in which
Yeah.
years?
They're reporting
So this was for students born between, so students who took the class 10 or class 12 exams between 2005 to 2012, which is roughly a little over 1 crore students.
That is because, the dates are wrong.
maybe they keep.
School data.
Exactly. And the reason why we concluded with this hypothesis is because look at the stripes on the 5th, 10th, 15th, 20th, 25th.
Convenient days.
When you're hooking up numbers, you hook up round numbers.
And everybody who was born in August was pushed up in July.
Exactly. So, and anyone born subsequent months in general gets pushed to June, July, and when you're making up the date, you say, okay, 15, 10, 20.
Easy numbers.
Exactly.
Which is why the results for July are particularly bad, right?
And the results are like 10, 15, 20. So if you push up the students, obviously that date ends up being a bad date on average. There probably is a weekday pattern.
So which that would suggest that 15th, 20th and so on in January, February should be less poor performing than in July. I mean, so because people are not going to push their kids from August to January.
Let's see. So, but it looks like some of them are, because I can't think of anything else that would explain the
But
January.
it's starker.
Yeah, absolutely. The closer you get, the worse it becomes. So more people are probably pushing them into just before the admission date than 6 months before the admission date. The only analysis we've done here is take various segments, find the averages of various segments. In this case, we just happen to choose the month and the date for the segment. Let's do this analysis. What we have is a subset of the data that contains each student's marks. And by subset, I mean just a column subset. I ignore the school names, the parent's name, the child's name, and so on. There is you can do a lot of interesting things with the names, by the way. But let's just see if we can get the day of the week that they were born and see what implications that has. So Excel has this weekday function. So if I say weekday equals weekday of a date, it gives me the day of the week, and it's a number from 1 to 7, where I don't know. So let's see, weekday of today is 2. So that means Monday is 2, Sundays must be 1. So Sundays are 1, Saturdays are 7. Let's take this and paste it across the full list. Okay, it's finished that taken. Let's do a pivot table. Which will take sweet time. we'll take your weekday. Remember that Sundays are 1. We take the total marks and we'll get the average of the total marks. And see what the pattern looks like. Sundays, relatively low, but not as bad as Monday, Tuesday, Wednesday, not as bad as Wednesdays. Don't know why. Who knows?
Maybe 10th of that particular year
Was more often for this data set?
10th or 15th or something.
Possible. So, in which case, for those of you who are doing this project,
Or
just
August had more Wednesdays, July.
had more Wednesdays, quite possibly, quite possibly. In which case, and if that happens to be true, you need more data to see what the broader pattern is. Just let me know. I have 7 years worth of data. Let's move on. What else can we figure out from this? Let's take some of the other categories and see what this data shows. If we take the caste code, there are 4, and that's the number of students, that's the distribution of total marks, and the distribution of marks by subject. So, others clearly high, followed by Cat 1, I have no idea what these categories are by the way, followed by SC and ST, which are substantially lower. And that is something that spans across most subjects. However, in Hindi as a first language, it appears that ST does rather well. We'll have to see how large this is to see if it is a significant result. I'll come to the significance of results in a short while. But assuming it is, then it means that Hindi as a first language is probably the right thing for SC students, SP students, not necessarily for SC students.
Unless it turns out that STs are primarily from Hindi-speaking backgrounds.
Yes, which is all the more a reason for them to. I haven't put in Sanskrit here, but for others, the others category, there is almost no doubt whatsoever that Sanskrit is the subject you want to pick. The averages are way above anything else. And from what I understand, this might be called conventional wisdom. I met a number of people who say, yeah, of course, that's why we took Sanskrit in the first place. So,
They can write it in their
They
spoken
can
language.
write spoken language.
So that's why.
which interestingly seems to go on up to PhD in Sanskrit College at Chennai. PhD theses are not written in Sanskrit; they're written in English or Tamil or pick your language. Which is
It's more than that, it's like maths, you score 100%. That is
Exactly.
the way it is tested.
Yeah.
Same pattern goes with the IAS exams also. People, tend to pick up Sanskrit as one of the papers.
Absolutely, but it's interesting that you say like maths
That's what I was
because
about to say. Look at that.
Yeah.
there is probably only one subject that does. In this data set, it doesn't come out, but if you look at the distribution of marks as a pattern, most subjects are slightly skewed towards higher marks. You would expect a somewhat normal distribution, but it tends to be skewed a little towards higher marks. The degree of skew varies across subjects. The least skew is in English, and almost as low a skew in mathematics. In the sciences, you'll find a slight bias towards higher marks. In social sciences, you'll find an even higher bias towards higher marks. In the languages, you'll find a very strong bias towards higher marks. And especially if it is the state's language, you'll find a very, very strong bias. Anyway, that's one kind of implication. What about the medium of instruction? What impact does teaching in Kannada versus English versus Urdu versus Marathi, Telugu, Hindi, Tamil have on the various subjects? I'm not going to go through this analysis. You'll have the slides. And remember that anything below the last 3 rows, don't draw any conclusions from those. With 600, 300, 200 students, it may not be as meaningful as with the